In this question, it's given that let f takes r to r be a function such that fx equal to this thing, then you have to find the correct choice. From the choices, it is clear that we have to check about 1 of the function. For a continuous function, for the function to be 1, it should be always increasing or always decreasing. If the function is sometimes increasing, sometimes decreasing, then that function cannot be 1. This concept I will be using in this question. It's clear that fx is equal to x plus 1 whole square upon x square plus 1. That is f dash x is equal to into 2 into and x plus 1 whole square into 2x. That is 2 into x plus 1 x square plus 1 minus x into upon this is equal to 2 into x plus 1 minus x plus 1 upon and putting it equal to 0, I get the value of x as minus 1 and 1. That is fx will have turning point at minus 1 and 1. It's clear that if x is slightly more than 1, this will be positive, this will be negative. Hence, for x more than 1, it is negative. That is, f dash x is negative for x more than 1. And note that it is not required to check the sign of it for x less than 1, because checking the sign of it for x slightly less than 1 is wastage of time, because note that 1 is the root of this only once, and the number which is root of f dash x only once, at that number it is sure that maxima or minima is there. And because I have found that for x greater than 1 f dash x is negative, hence it is sure that for x slightly less than 1 f dash x will be positive. Hence I can say this function will have local maxima at x equal to 1. And because there are two turning points, if one is giving local maxima, the other turning point will surely give local minima, because maxima and minima always come alternately. Note that all these things are applicable when the function is continuous. And it is clear that because denominator is never equal to 0, hence this is a continuous function for all x. Hence, if 1 is giving local maxima, x equal to minus 1 will give local minima. And local maxima means for x greater than 1, fx will be decreasing. For minus 1 to 1, fx will be increasing. And for x less than minus 1, again fx will be decreasing. because -1 is giving local minima. That is, on the number line, I will say here it is decreasing, here it is increasing, and here it is decreasing. And in first choice, he is discussing about the interval -infinity to -1. In the interval -infinity to -1, because the function is decreasing and the function which is always increasing or always decreasing is sure to be 1 1, because the function which is always increasing, that is sure to be 1 1. If you know the meaning of the word 1 1, this is not difficult to see. And if the function is always decreasing, that function is also 1 1. And because fx is decreasing in the interval -infinity to -1, hence fx will be 1 1, but it is giving many 1, therefore first choice is wrong. Many 1 in the interval 1 to infinity is also wrong, because for x more than 1, function is sure to be decreasing, hence fx is many 1 in the interval 1 to infinity is also wrong. Third choice, fx is 1 1 in the interval 1 to infinity, but not in the interval -infinity to infinity. Yes, it is correct, because for x more than 1, it is sure to be decreasing, therefore 1 1. But in the interval -infinity to infinity, it is sometimes decreasing, sometimes increasing, hence the function cannot be 1 1. Because if the function is sometimes increasing or sometimes decreasing, etc., of this type, then the function cannot be 1 1, because if I draw a line perpendicular to y-axis, that line will cut the graph more than once. And if there is even one line which is cutting the graph more than once, the function cannot be 1 1. Hence I can say third choice is correct.